Hi friends, good morning. Today we are going to discuss about oil hydraulic circuit. So this is our fourth video regarding control of double acting cylinder. Today we are going to discuss about the meter out circuit. So what is meant by meter out circuit? So meter means to control the flow rate of the oil, and when this flow control valve with the check valve is placed at the outlet of the actuator, then it is called as a meter out circuit. Means whatever the oil coming from the outlet port of the actuator, that get control with the help of variable flow control valve along with integral check valve, and this whole circuit is placed at the outlet of this actuator. That's why it is called as a meter out hydraulic circuit. So this circuit consists of number of components. So today in this video we will discuss about the function of each component and working of this meter out hydraulic circuit. So the first component of this circuit is the reservoir. So the function of the reservoir is to store the oil and supply the oil to the system. Then second component, filter. So in the market there are different types of filters are available, and the function of the filter is to remove the impurities from the oil, means to purify the oil and supply that purified oil to the system. Then next component, pump. So pump is the heart of this hydraulic system. So the function of this pump is to increase the pressure of the oil and to supply the pressurized oil to whole circuit. So it works on the principle of to convert mechanical energy into hydraulic energy, and this pump is run with the prime mover, that is electrical motor. So in this diagram here, the shaft of this motor is coupled to the shaft of pump, and this pump is drive with the help of the prime mover. Then another component of this circuit is the pressure relief valve. It works as a safety in this circuit. So the main function of this pressure relief valve is to release the excess pressure. Okay. Then next component, that is 4x2 push button operated direction control. So the function of the direction control valve is to control or to change the direction of the flowing fluid in the circuit. So in this DC valve there are 4 ports. Port number 1, that is inlet port, then port number 2, port number 3 and port number 4. Okay, so this is the first position. In that first position there are 4 ports, and in second position again there are 4 ports. So in this direction control there are 4 ports and 2 positions. So one block shows the one position and another block shows the second position. That's why it is called as a 4x2 direction control. Then another element, that is variable flow control along with the check valve. So here the flow control valve is used to control the flow rate of the oil, or as per our requirement here we can change the flow rate of the oil by operating this variable flow control valve. If our demand or requirement is to obtain or to achieve faster speed of the actuator, then here we have to keep the maximum opening of the flow control, so that maximum quantity oil will flow through that flow control and it will admitted inside the actuator, so that the actuator will run with a faster speed. Then here along with this variable flow control, check valve is there. So the main function of the check valve is to permit the flow of the oil in only one direction. This check valve is also called as a non-return valve. It does not permit the flow of oil in a reverse direction. Then another component, double acting cylinder. So why this cylinder is called as a double acting cylinder? Because this cylinder having the 2 ports, X is the inlet port and Y is the outlet port. So there are 2 ports, and this linear actuator consists of cylinder, that is the outer body. Inside the cylinder piston is there, and to that piston rod is connected. So in this circuit we have to obtain different speeds of the actuator by using this variable flow control valve. So all these are the parts of this hydraulic circuit. Now we will discuss about the working of this hydraulic circuit, how to obtain the linear movement of this actuator by using different elements. So here when this pump starts, then it sucks the oil from the reservoir and increase the pressure of the oil. So that pressurized oil gets supplied through the pump it passes from port number 1, that is inlet port of this direction controller, then it flow from port 1 to 2, then it get admitted inside the actuator to its inlet port X. When this pressurized oil admitted inside the cylinder, then it will exert the pressure on the piston. So this piston move in forward direction, and when the piston comes to this last position or end position, then whatever the oil present in piston rod end zone, okay, that oil will start to flow through port Y, then flow control and some oil flow through the check valve, and then it finally goes to the reservoir through the port 3 and 4. So here the forward stroke completed. So this is the way of flowing of the oil. So the oil flow from pump to port number 1, then port number 2, then port X. Okay, then again it flow from port Y, that is the outlet port of this actuator. Then it flow through the flow controller, then port 3, port 4, and finally it goes to the reservoir. In this way it completes its forward stroke. Okay, if we here keep the minimum opening of the flow controller, then whatever oil coming from this side through this flow controller, there is a restriction to that flow controller, to that oil. So what happened? So here the forward stroke or forward movement of this actuator will be slower, and if the maximum opening of this flow controller is kept, then a large quantity of oil flow through this flow controller, so that here we can obtain the faster movement of this actuator in forward direction. Now when I operate or push this push button of this DC on, then we will get the second position. So in second position, the direction of flowing fluid get changed. Okay, so the oil flow from this pump, then pump to port number 1, then from port 1 to port number 3. From port 3, then it flow from flow controller. It does not flow from this check valve or non-return valve. Okay, then it will admitted inside the actuator through the port Y. Okay, then it will exert the pressure on the piston, so that this piston along with the piston rod move in backward direction. If I keep the maximum opening of the flow controller, then large quantity of oil will start to flow through this flow controller, and it exert a maximum pressure on this piston, so that this piston move with a faster rate in a backward direction. And if I keep a minimum opening of this flow controller, then less or minimum quantity of oil flow through it, and it exerts a less pressure on the piston, so that this piston move in backward direction with the lower speed. Okay, then whatever the oil present in this area, that on a piston side end, it will flow through port X, then port number 2, then port number 4, and finally it reaches to the reservoir. And in this way it complete its return stroke. So again, if again I operated this push button, then again the oil flow from pump to port number 1, then port number 2, then again it admitted in the actuator through its inlet port X, again it moves in forward direction. Again whatever the oil present in this area, it goes to the reservoir through the port Y, flow controller, port number 3, port number 4. In this way the cycle get repeated by operating this push button. So here, with the help of this variable flow controller, here we can obtain the different speeds of the actuator. So as per our requirement of the speed of the actuator, here we can obtain by using this flow controller. So this is about meter out circuit. Thank you.